this is going to count as at least 2 quiz grades. I gotta double check the way I want to do it. But the way you do your notebook paper is going to be a lot with that grade. So each time we do a problem, we're going to go through problems not beginning to end, but most missed to least missed. So keeping up with the order is going to be kind of funny, and you have to make sure you do this right, otherwise you can't keep up with it, neither can I. So the very first problem we're going to do is like number 34. So over here, I need it very obvious that we are starting with number 34. There are some problems that you're going to have a giant chunk of the paper written for that problem, and some of them are just going to be a little bit of work. I need it very obvious that all of this section goes with that problem. Then we go to the next problem. This is the number that all that goes with. So I'm literally going to go through your paper and count these and make sure they're in order and everything. So make it very obvious where the problems switch. And that way it should make it really easy for you to get the grade and me to grade them. I'm not looking to try to play gotcha with anybody and count stuff off. But when I sit here and scan through 55 of them, it's pretty easy to tell if you did it or didn't. You may write things in here. So like we may start talking about problem number 34, and I might go off on a tangent and we start writing stuff. That's fine. If you still write it there, you can still write it as that goes with problem number 34. Oh, yes. Okay. The other thing is I have not given you anything to do with grades. So what I would do is, like I said, that little half sheet where you have your answers as we go through them, put like a check or X or something, so that eventually I'll send it back to you, but that way you can kind of keep up with the ones that you got right and wrong as we go along. Any other questions about stuff like that I just forget to say? Alright, and I don't care what you want to do with colors, not colors. I don't care if you choose to mark directly on the paper itself that you've already written on. My only thing is if you do that, I would do it in a different color so you can tell that stuff that was written when you did it versus when we went over it. But this is one thing that I guess a lot of people end up doing. I forget to say. Anything you write on your paper that I gave you, I am not going to scan through when I'm grading this. So even though you can write stuff on there, I wouldn't write much on there because I need to see that you're doing this. I'm not going to sit and go back and forth through these pieces of papers. Everybody good? One thing about today is I am starting with the most missed problem to the least missed problem. And I need you to know that ahead of time, number one, for your confidence as we go through today. I do not care how slow we go. I don't care if it takes us 3 days to get through these 40 questions. I don't care if we go off on a tangent with every problem and ask about a question that's not the question. If we do this correctly, you will get a lot out of going over this. So I don't care what we change, how we do it. If you're all of a sudden like, wow, this question has nothing to do with this question that I have, but it made me think about something, that's fine. Stop, let's ask it. But don't feel very deflated if we go through a lot of problems today and you haven't gotten any or many right, because I'm starting with the most missed. All right, so flip to number 34. On your notebook paper should say number 34. Any other questions about format, which how I want to go? A researcher has conducted a survey using a simple random sample of 50 registered voters. Okay, so hopefully you've gotten in the habit of there's simple random sample, there's N. To create a confidence interval, to estimate the proportion, we're doing proportion stuff, of registered voters favoring the election of a certain candidate for mayor. Assume that the sample proportion does not change. So whatever it actually was stays. We're not like taking a different group. Which of the following best describes the anticipated effect on the width of the confidence interval? So the whole thing is talking about how is the width going to change. If we were to sample 200 instead of 50. So the big concept here is what happens. our sample size did what? If our sample size increases, what definitely happens to our width? If I interviewed more people, what happens to my width? It what? I shouldn't hear it said. Some of these problems that we're going to go over today, a lot of people miss because they're hard, and some of them we're going to go over that a lot of people miss, and I literally read a lot of my paper. This is a genuine concern. This is one of those that I was a little bit concerned of, because at this point, how many answers should I be able to mark out? They are definitely not going to be the same. They are not going to get bigger. They are not going to get bigger. And I had a chunk of people choosing those three answers. Now, I'm hoping that at least some of those people accidentally read it as 50 instead of 200, and then maybe that's how they mixed it up. But a lot of them, if you could read this before you even get started, you should be able to narrow down your answers. So now, what part of every confidence interval, where is the sample size? I'm asking a very general question. In any of our equations, where is the sample size always? The denominator, and it's always what in the denominator? So it is here. So if we went from, and we're not changing whatever's up top. So we went from something over square root of 50 to something over square root of 100 or square root of 200. Well, how much bigger is 200 than 50? 4 times, but it's under the square root. So what is square root of 4? 2. So it is 1/2. Now, a lot of people are going to make up a number here and use something easy like that and type in 1 divided by square root of 50, write down the number, 1 divided by square root of 200, write down the number, and figure out if it's half or fourth, and that's fun too. But it's going to be 1/2. And like I said from before, we're going at your pace, so just absolutely stop me if you have a question. If I'm turned around the shelf, I don't care. But I get why some people would actually accidentally mess up and put A. We should be not getting to the point of C through E. But I understand we're coming straight back from break. I told y'all you didn't have to study or anything. All right, 22. And I'm going to start out making reminders as we go along because I don't have time to stop. So remember, under notebook paper, draw a line. Write number 22. Number 22 is a difficult problem, I think. But I'm going to go back and do it backwards at the end, and you can actually answer this whole problem without doing anything. So, a game of chance is played in which X is the number of points scored in each game. And it has this distribution. So what are our possible outcomes in the game? What are possible outcomes? 0, 1, and 2. And it tells us our different probabilities, 0.3, 0.4, 0.3. Which of the following is the sampling distribution for the sum if we play the game twice? And I'm hoping people just didn't see that. So, I played the game once. I'm just going to do this and do it back. If I play the game once, what are my different outcomes how many points can I get that game? I played the game once, how many outcomes, what are my possible outcomes?
0, 1, 2.
What is my probability of 0 points?
0.3.
Probability of 1 point?
0.4.
And 0.3. Now I played the game a second time. Could I have gotten 0 points the first time?
Yeah.
Could I have gotten 1? Could I have gotten 2? So does it change anything that's going to happen here? So I'm still 0, 1, 2, 0.3, 0.4, 0.3. Should have given myself more room. So even if you didn't choose to go this direction, does anybody have a question with what I just did? Okay. And if you're a little bit behind me writing, you want me to stop this one? So now I'm going to look at my different paths and see how many points I would have had. So on my first path, how many total points did I end up with? 0. I'm just adding. Then 1, then 2. Then I have 1 and 0. So 1, 2, 3, 2, 3, and 4. What else am I concerned with for each path? What does the problem also ask about for each path? The probability. So how do I find the probability of my first path? Just to get this 0, how do I find that probability?
Multiply down.
Multiply down. So here times here, which gives me 0.09. And all these are easy because they're either 0.09 or 0.12. So I'm 0.12, 0.09, 0.12, oh, there's 0.16, forgot about that one. 0.12, 0.09. So those are all my different paths. Then I could choose to redraw my distribution for y. My options are 0 points, 1 point, 2 points, 3 points, 4 points. How many of my paths ended up with 0 total points? How many of my paths ended up with 0 total points? 1. What's the probability of that path?
109.
And it actually ended up being the same thing over here, 4 points with 0.09. So what do I do if I want to figure out what's the total probability of getting 1 point? I'm adding across, so multiply down, add across. So I'm taking and so that gives me 0.24 and so forth. Also, just a side note, I'm going to record both of my different classes and post them separately. So if I'm like writing a problem and you realize you just got way behind, but you want to like listen and write it later, you might just want to write down what time it is, and then you can always go back and look at just that piece of the video. Alright, so then there's 3 paths with 0.2, which ends up adding up to 0.34. There's 2 paths with 0.3, which end up adding up to 0.24. This is one of your possible answers of the 4. Now that's a lot of work, a lot of time, and I don't think most of you would have thought to do that. And that's fine, I get that. But that's technically the way you should have done this problem. Now, is anybody still looking at this? Then I have to erase it, pull the problem back. Now, you could have done this problem without actually doing any work if you could think through it. I understand that each time I play, I can have 0 points, 1 points, or 2 points. And I'm putting those together. So are my only possible options 0, 1, or 2 points in 2 games? What are my possible options? 0, 1, 2, 3, 4. So that knocks out those 3 already. It gets me down to 2 options. Is the mean equal to 2? If I redrew that distribution, you can tell that it's somewhat symmetric. Even though I didn't draw that perfectly. So, do you see where the mean still is 2? But what does D say? What does that mean? To what?
2 outcomes.
So, in any of those stages, were there only 2 outcomes?
No.
So I didn't do any work and I just found out the answer is 8. Now, at worst case scenario, I would like you to start getting to the point where you can think through a problem to at least knock out A through C there. A lot of you probably wouldn't have thought to go to the tree diagram and would have been stuck between D and E, and I'm okay with that. Questions? Number 30. I always have an issue with this problem, this being one of most missed problems. Once I explain to you the problem itself is actually very easy, but it's complicated in the fact of it's almost like trying to hide the problem. A delivery service places packages into large containers before flying them across the country. These filled containers vary greatly in their weight. Suppose that delivery services airplanes always transport 2 such containers on each flight. The 2 containers are chosen so that their combined weight is close to but does not exceed a specified weight limit. So what this is saying is I've got a container A, I've got a container B. When I add these 2 together, I want them really close to but not going over some max weight. I'm going to make up numbers of what this is to deal with. Let's just say we're going to say they combine to equal 1. So what are 2 numbers that I can combine to equal 1? Or about 1. We'll just do it exactly equal for right now. So give me 2 numbers that equal 1.
0.5 and 0.5.
That's an option, right? So give me another one.
0.1 and 0.9. 0.9 and 0.1.
Give me one more.
0.3 and 0.7.
As our numbers for A got bigger, what happened to our numbers for B?
Smaller.
So what kind of relationship do they have? And that's why I don't actually love this problem. The problem itself is easy. What it is asking is not written well. What would it mean to have a correlation of 1?
Perfect.
Perfect and
Positive.
positive. So like, even if it were, if those are my A's, that would be a perfect correlation because they're all multiplied by 2. $33. An independent research firm conducted a study of 100 randomly selected children who were participating in a program advertised to improve mathematics skills. Results showed no statistically significant improvement using alpha equals 0.05. The program sponsors complained that the study had insufficient statistical power. Which is not necessarily a way we usually talk about that problem. Assuming that the problem is effective. So it actually basically should show good results. Which of the following would be an appropriate method for increasing power? The only thing that matters in this whole problem is basically how do you increase power. Let's go with we usually talk about three things together: power, what, and what. Power, alpha, beta. What usually goes here when I do this thing? Before that. So if it's this one, we should what?
Filter it.
I think about the way I usually read it. So I think I usually read it this way. And I would not expect most of you to have to go through all of what I'm talking about right now, but like I said, I want to cover more than the problem. What is this first path called? If it's true, but I rejected it. The second one we don't usually call anything. What's my third one? Which is, I'll say correct. What's this one? What do I associate with type 1? Because alpha is the probability of a type 1 error. What's my probability of type 2 error?
Beta.
And what is this one?
Power.
Well, these two are on the same branch, but going opposite directions. So power and beta are what? Are inversely related. The negative, as one goes up, the other one goes down. What about alpha and beta? So if power and beta are inversely related, alpha and beta are inversely related, what about power and alpha? How are power and alpha? So as one goes up, the other one goes up. As one goes down, the other one goes down. What are we trying to do here? Get a higher power. What does C tell us? To lower alpha. Well, if they are directly related and we want to increase power, we want to increase alpha. A lot of people who missed this problem chose that one. This is a lot of work to get there, but it's more of a reminder. If we ever want to make a test better results, what's the easiest thing that we could possibly do? Increase your sample size. And power is that ideal scenario. So increasing your sample size is the easiest way to increase power. Any questions? I'm going a lot faster than I really wanted to. All right, 21. And just keeping people on track, this should be the fifth problem that we are doing is 21. An experiment has three mutually exclusive outcomes, A, B, and C. dealing with outcomes, what does the box represent?
Oh, okay.
All possible outcomes. That's our entire sample space. If all three are mutually exclusive, how do I draw them here? Make sure that none of them are what? So, concept of what it's saying is this. I'm going to kind of skip around here. And would be represented as the what? Where two things what?
Overlap.
Well, where do A and B overlap?
No.
They don't, which is what this is saying. So is that true? So is number 2 true? Yes, no, yes. Or usually we deal with and when we're dealing with independent, dependent. Usually dealing with or when we're dealing with mutually exclusive, not mutually exclusive. You don't need to write this. But just a reminder. What would go there?
A and B.
When do I use this one?
When they're mutually exclusive.
And when would I use this one?
When they're not.
Well, they are mutually exclusive, so is that correct?
Yes.
Sorry, I'm just giving y'all time because I don't have to erase that. Like I said, I'm more than willing to slow down, so if you need me to, if I erase something you want me to put back, I can. This is probably going to be a good refresher for people. How do I check, or how would I prove to see if two things are independent or not?
If the probability of something is equal to the probability of it given something else.
The probability of something equals probability of that thing given something else already occurred. Now, I should have done A and I'll switch my letters. I can do A and C up here and just switch this to B, C. What is the probability of A? Given this problem. 12. What does it mean to be, what does this right there mean? What does this part read as? Given C. So given that I am in this circle right here, what is the probability that I'm A?
0.
So are those equal?
No.
So are they independent? I would not be surprised if some people didn't get that part right, just because they forgot how you check independent. I was more concerned with the fact that a lot of people chose C instead. So not only did they not get that they shouldn't have done number 1, but they thought you shouldn't have done or they got this one wrong as well, and that's more of my concern. That one should be an easy one. So your answer here should be D. And I'm really bad about when I go over these, I talk through the whole problem and don't ever clearly say what the answer is. If I do that, just tell me. Questions about anything with mutually exclusive, not mutually exclusive, independent? At number 12. Random variable x is normally distributed with mean 10, standard deviation 3. And then we have random variable y is also normally distributed, mean 9, standard deviation 4. It asks us to combine them, and combine them how?
Y minus x.
Y minus x. Now, there are going to be some people who miss this problem because they did the easiest part of the entire problem wrong because they weren't thinking about it. They gave us x, then they gave us y, and then they asked us to do y minus x. So make sure you don't mess that up. So I know how do means work when combining.
Very simple. Just like
Exactly the way you would think it would be, the simple way. So mu of y minus x is mu of y minus mu of x, which is 9 minus 10, which is negative 1. Which should knock out A and D. Wait. Oh yeah, my paper's weird. Oh, y'all's answer keys, like your answer choices just don't look straight like this, right? I've reformatted the thing so many times I forget. But it's still A3. Hopefully the tricky part of this is the second part. What do we always have to know about how we, 2 rules with combining? About combining standard deviations. 2 rules, what's one of them?
yeah.
So this problem told us to subtract, but we know when we put them together, we can only add. What is our second rule? Only combine as variances. So regardless of if I'm adding or subtracting here, I put them as variances, which is like that. I have to add, and then so what does that mean I have to do at the end? I have to take the square root to switch it back to standard deviation. So what is my variance of y? And I have to add, what is my variance of x? Well, 16 plus 9 gives me what? So my standard deviation is 5. Even if you forgot that, you should look and see, well, 9 minus 10 is not going to give me positive 1. Which means my 3 options would be a standard deviation of 1, a standard deviation of 5, a standard deviation of 7. If I'm combining 2 standard deviations, is it ever going to get smaller? So that should leave you with 2 answer choices. But this is the main thing with this problem. At 27. Histograms below represent the distribution of 5 different data sets, each containing 28 integers from 1 through 7 inclusive. The horizontal and vertical scales are the same for all graphs. Which of the following represents the largest standard deviation? I want to talk about the first half of this problem first because this type of problem tends to show up often on the AP exam. What they mean is this bar represents 1, this is 2, 3, 4, 5, 6, 7, and every single one of them. Whether you knew this or not doesn't necessarily mean it could keep you from doing the problem, but I want to explain this part. Each containing 28 integers. So I'm going to do an easy one right here. It looks like these each go up by 1. So this is probably 1. This is 2 of them. There's 3. There's 4. There's 5 of these, 6 of these, 7 of these. So this frequency is 7. So if I added up all these frequencies, there's 8, 16, 24, 28. That's what all of this part means. Like I said, you can answer this problem without using any of that, but I'm also going to show you how to answer this problem using that. So let's look at C and D. The middle is definitely, it's symmetrical, so the mean is the exact center. Where is the majority of this data in relation to the mean? Close to the mean. So this right here, this tallest bar would have a pool of 0 from the mean. So like it's contributing a pool of 0. Here, where is most of it? Away from the mean. So there's a lot of contribution away. Where I have almost no pool of 0. So of those two, which is going to have the higher standard deviation? D. And if you need me to write that out, this would be like, this contributed 3, this contributed 2, this contributed 1, these contributed 0, these contributed 1, these contributed 2, these contributed 0. So like this one, looks like it's probably like that as far as frequency bars. So there's 1, 2, 3, 4, 5. This would be and so forth, and then I could find those if I wanted to. Now, E, how would E relate to C and D? So here would be a pool of 0, here would be a pool of 3. So if I wanted to put C, D, and E in order from largest to smallest standard deviation, which would be our largest standard deviation of those, of just C, D, and E? Which is our smallest? Which one has a lot of no pool? And this would fall somewhere in between. Because I'm not saying I have a whole lot of pool away, I'm not saying I have a whole lot of pool at 0, so I would fall somewhere in between those two. What's going to trip a lot of people up is just looking at these two. And you could really kind of drive yourself insane by looking at these two. Here, why were these 3 really easy to know where the center is going to be? Because they're symmetrical. These are not, which makes it a little bit harder. So this one's probably going to be, well, the center would be here, but I have more that way than this way, so it's somewhere shifted that direction. Somewhere around in here. Same thing in here, which gets a little bit complicated. because I'm not sure because of this switch. Somewhere around in here. This one is going to put less pull farther away. I don't like getting too confusing about this. I'll show you a different way to talk about this one. I am now closer to this bar up here. And how much does it contribute? It contributes a lot, but I only have one contributing a lot. Whereas here I had it from both sides. And I have over here contributing a lot, but there's not much. Does that make sense? Which do you think is going to contribute, have a higher standard deviation? Something from A and B or D? Let's look at it this way. Here I have 1, 2, 3, 4, 5, 6, 7. Here I had 1. Here I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here I have 10 contributing as far away as possible. Here I have 8, and this is actually sliding towards 7 a little bit more, so it's not even contributing as much as those were. Does that kind of make sense? Like, I think this is a very difficult problem. Now, I'm going to teach you a different way to do this, where if you were stuck and you had time, or you're like me and this problem drives you so insane you can't go past it, I want to show you how you can use the calculator. So you most of the time if I do something in the calculator, I'm going to want you to type it in with me. This one, I don't actually need you to. Watching me is fine. I can basically go in and type these in. So like, let's say I'm stuck between A and B. Now I'll make it easier and say D and A. I can go in, like I said, this is definitely a long way to do it. And there's an easier way to do it, but I don't want to confuse people. And for problem A, the way I just did it, and you can sit there and draw lines across, how many did we say contributed? How many ones were there after I drew the lines on the board? For A, I think we decided 7, right? So I could go in here and type in 1 7 times. And then how many 2s were there? 6. And then how many in A, how many 3s would there be? 3 4s, and then 1, 2, 3, 4, 5 4s. Help me out. 3 5s, 2 6s, and a 7. So I've just gone and typed all the numbers in. Well, then what can I do from there? What am I trying to figure out? Standard deviation. How do I do that? Stat calc, one variable stats of that list. And I can do this and figure out, well, the standard deviation is this. And then go type in the list for another one and figure out the difference in the standard deviations. Now, as you're going through a multiple choice test, I do not suggest doing this while you're going through and wasting a lot of time. But if you get to the end and you're stuck between two and you have extra time, this is a way that you can think through it. So I'm kind of just showing you this as another tool for any type of problem, because you will see a lot that look like, you'll probably see at least one that looks like that, where you can kind of break it down and give numbers and associate it. Even if they didn't give you the numbers 1 through 7, I could make up that they're all 1 through 7, or that they're all something through whatever, and just use the same numbers for all of them. That'd be fun too. So questions with the way I explained that one. All right, so what is our answer here? Which one's going to contribute more, A or D? I think I would need you to be okay with the difference between C, D, and E and feel good about putting those three in order, and then kind of work your way towards working in the difference between A and B with those. All right, our 8th problem. This is problem number 18. No, okay, so some of those I keep talking about, well, I feel good if you can narrow it down to 2 and that kind of thing. I think this one's a tough problem the way it's worded. You have to think through a bunch of different things. A t-statistic was used to conduct a test of null hypothesis of mu equals 0 against the alternative of mu is not equal to 0. The p-value was 0.056. A two-sided confidence interval was to be constructed of the following, which is the largest confidence interval for the confidence interval which will not contain 0. Just thinking through this. Why did it say this number? Where did that number come from? Why did I choose 0 here? So if that number were 7, this number would be 7. Those should be the same. What would it look like in my picture for the confidence interval to not contain 0? In general. One of the shaded parts. And it can be either one, but when I look at this from a test perspective instead of a confidence interval perspective, what would we choose to do if it were there? If I were running a test and my line fell here, my decision would be to what? Is everybody with me with all that? And all these tiny little pieces that connect, this is why I think this is a hard problem. And we've done one that's similar to this on one of our test reviews. All right, when do we reject? When what? And now I'm getting my own way here. So in all of these, our p-value was 0.056. If I have a 90% confidence, what does that mean is left for my alpha? So this is what's between, so how much is not between this 10? So here would be 0.7, 0.5, 0.2, and 0.1. 0.056 is what to 0.10? This one would be what about my third one? And just the way I talk about it, not less than, not less than. So if it is telling us we reject, which of those reject? And then the problem says, which is the largest confidence that does that? Which of those is bigger? There's a lot of pieces to that one problem. I think that is a difficult problem. I am more concerned with you being able to follow everything I did and understand what I did, even if you wouldn't have come up with that on your own. All right, 16. This is one that's really straightforward. Either you knew what you couldn't do, or you didn't. As opposed to most of the other problems we've done so far where there's a lot of work behind it. It gives us two different samples. They have different sample sizes. And it also gives us the mean and the median for both of them. What is my equation to find the mean? How do I find a mean? In general, yes, you're saying it right, but what if I don't know how many there are? How many numbers are in a data set? How do I find the mean of a data set? You guys would tell me this before you ever had my class.
Add them all up and divide by n.
Add them all up and divide by how many there are. How do I find median? Just in general. Median is the what number?
Middle.
The middle number. Do I have an equation for it like this? No. If I want to put them together, mean has an equation that I can go through to get there. Median does not. So, can I just look at these two data sets and know where the new median is going to be? No, because I can't go through an equation to get there. But I can do that with means. So if it asks me to combine means here, I basically have to undo it. So how would I think about it like money? I have 21 people who average $42.60. How do I figure out how much money a sample one had? So if there are 21 people and they average this much per person, how much money did that entire sample have?
42.6.
I can do the same thing with my second group. And then if I want to split it equally among all of them, I now divide that by what? So this is the correct way to find the combined mean, but we cannot find the new combined median because we don't have an equation to go through to get there. When is the only way it would be okay to go through the process of A to find our new combined mean? Why can we not do that problem with, why can we not just do A with this one? Because they're different sample sizes, so you have to have it proportional to the size. So you would need the actual data in order to find the combined median. Alright, this one concerned me a little bit, mainly because it's not the only problem that we had that I've already talked about that talks about the exact same concept. The graphs of sampling distributions 1 and 2 of the sample mean of the same random variable for samples. So I am collecting it from the same data. Well, if both of them are centered here, that means the mean of both of them are 10. That's all that this is saying. We're taking the same one. The only thing that's different is we're taking it of two different sizes. Before I even read this, What word would I put there? What are some words I can put there? Taller. What else? So talk about it this way. Wait, is narrower a word? Yes, right. So which one of these is going to talk about, which one of those is going to be affected by a change in sample size? Width or height? Width. I mean, technically it's both, but we talk about it as width. So if 2 is wider, so one is narrower, which one is going to have a bigger sample size? What makes it narrow?
A larger sample size.
So because it is narrow, it's because of our larger sample size. So all these are talking about sample size. They're not equal. It's the only thing that changed, and the distributions aren't equal. Definitely does affect it. It definitely can be compared. So that means sample size of 1 is greater than the sample size of 2. And that's a very straightforward question, and that's kind of why that one concerns me more. And I had 45% of people chose D and E, and that's the concerning part. At 23. This is a straightforward problem, but I get why people miss this one. So Julie generates a sample of 20 random integers between 0 and 9. So how many options are there? Between 0 and 9 inclusive, that's how many options? 10. She records the number of 6s. So we're deeming 6s as our what? Then she ends up repeating it 99 more times, recording the number of 6s in each, so forth. If a 6 is success, that means the probability of our success is what? And that should definitely knock those two out. So at this point, basically what's one obvious difference between B, C, and D?
Binomial distribution.
Binomial distribution as opposed to sampling distribution. And what else? N. So let's think about N. When we did this is the part where I get where people mess this up. When we did the coin flip example, we actually flipped the coin 20 times, and then each group put dots on the board. Did it matter that we flipped the coin 20 times? Did we ever talk about how many dots were on the whole board? Did you care how many dots were on the board? We just kept putting dots because people kept flipping coins. So which is the important part? The n equals 20 or the n equals 100? Each time we did it, what was in? Each dot that was up there, what was in? Each time you put a sticker up there, what was our in? Like you flip the coin, you put a sticker. So the end that goes with that one sticker is what? Which is how many? Which was 20. The 100 is just how many dots there were. I can sit there and flip coins and put more dots and more dots. That just means it's going to get closer and closer to that. This goes from, for each trial, we did it this many times. The N is just how many dots there are up there. Or the 100 is just how many dots there are up there. And really, the differentiation between binomial and sampling distribution could be used correctly for either one of these. I think that is a tricky problem. Or I understand why people get tripped up with that problem. But you should definitely be able to knock out A and E. $32. This one is definitely concerning. Consider a data set of positive values, at least 2 of which are not equal. Which of the following sample statistics will be changed when each value in the data set is multiplied by a constant whose absolute value is greater than 1? Most of you are going to read about a third of those words and be okay with it and never think about the extra words that were added in there. I'm going to multiply everything by some number. Which things change? You have, let's say it's a quiz, and it's a 10-question quiz, and I go from number of questions right to a score. Is your mean going to change? The number of questions right versus your actual score. Yes, so if it's like 7 questions right, that might be a 70. So that's going to change. Is my median going to change? Is my standard deviation going to change? I want you to write this. If I add and subtract, are my centers going to change? I'm going to write it down first. What always happens to my mean? In general, we talked about this earlier. How do you know mean is always going to work? It's a very general way I say this. How does mean always work? Exactly the way you think it would. So what's going to happen if I add and subtract, my mean is going to change? If I multiply and divide, my mean is going to change. It does exactly what you think it would. Anything with spread, standard deviation, interquartile range, that type of stuff. Which one are they changed by? Multiply, divide. Because if I take some blob and stretch it, that spread is going to change. If I take some blob and shift it, does that blob change? Does the width of that blob change? So this is the one that's your big difference here. Your spreads are the ones that are not affected when it is adding and subtracting. What happens to shape when I add or subtract? What happens to shape when I multiply or divide? So this one basically comes down to the fact that I multiply and divide. These are centers, that's a spread. All of those get changed by multiplying and dividing. To be a little bit more picky here that most people aren't going to look at, you know why it said this, why it mentioned this part? There's one of those that actually wouldn't have changed if that weren't in there.
Because if they're all the same, the standard deviation would be 0, and 0 times anything is 0.
Right. So if they were all the same, standard deviation would be 0. Even if I multiplied them all by something, they'd all still be the same, so standard deviation would still be 0, which is why that's in there. And then this is also talking about something that can happen with the way it changes. But, so what's our answer here? E. And number 4, it should be your 13th one on notebook paper. This one I just wrote right beside it because I don't know why people miss this, and I definitely don't know why it is the 13th most problem. This one scares me a little bit. I'm going to draw a little bit more than I have to start out with, but I'm going to erase it just so we're all on the same page. The distribution is normal with a mean of 100, standard deviation of 10. Well, all of these numbers only use 115 or 85. What's important about using 115 and 85? They're the same distance either way. So this is 1 standard deviation, this is 2 standard deviations, and I can go through the math here and do it. So like if I do, well, 85 minus 100 is going to give me what? 85 minus 100 gives me what? Negative 15. Negative 15 divided by 10 gives me. But if I switched it and had 115 instead, I would get what instead? 1.5. So I'm dealing with z's of 1.5 and negative 1.5 throughout the whole thing, which I would need to know that, but I'm kind of shorthanding that. That's why I just did that part. So here, I'm taking my positive 1.5 and shading which way? For A. What's the difference between A and B? What's literally the difference on the paper? Does that make a difference when I'm doing these?
No.
No. So those are the same, which means neither of them could be the answer. C is now coming down to negative 1.5 and shading which way? D, I've got both, and I'm shading between. And E says, instead of shading to the left of negative 1.5, I'm going to do the opposite of that, which means I'm actually shading which way? Is everybody okay with those? So this one The one it's actually asking to say it's the same as, am I starting with 1.5 or negative 1.5? Positive or negative? And which way do I shade? Which one of those is equal to that one? And that should be a very, very, very easy problem. That's why that one concerns me, that it's the 13th most problem that we did. I'm hoping people just thought it was easy compared to some of the other ones and just did a little too quick. Number 7. Which of the following is not a characteristic of a stratified random sampling? It's concerning that this one was here too, but I at least understand why this one was one. Like, you either knew this part or you didn't. I'm gonna get that. So let's talk about more than just this problem. In both cluster and stratified sampling, my very first thing is I have to put them what? Into groups. What is important about how I do the groups for clusters? Yeah, you're saying the right thing, but I'm just thinking about the way that most everybody's gonna relate to it. I always just say crab legs. Crab legs was over break, and I always think cluster sampling. I mess myself up with that. This is not something I usually write, but I've seen a lot of it on your paper this year. Does anybody write it this way? Similar what? I must have said something different this year because a lot of you have written it this way and gone with it, as opposed to stratified, which you would write as what? And that seems to be the way most of you are relating it, but everything you were saying was right. So this one, I want each group to represent the population. So like the crab legs, I've got some small ones, some big ones. This one, I want each group to be similar itself. So like freshmen together, sophomores together, and so forth. The other thing that's important is how do we select? How do we select the cluster? And sometimes it's just one and sometimes it's multiples. As opposed to how do we select the stratified? The same amount or proportional group from each. So I want to make sure that I have some sophomores, some freshmen, some juniors, some seniors. Whereas if I take crab clusters, each cluster should be representative of the population. So I only have to take entire clusters. All right, so now, should random sampling be a part of both of those? Yes. So random sampling is part of the sampling procedure. Well, yes, it should be. So we're just talking about stratified now. The population is divided into groups of units that are similar on some characteristic. Yes or no? Yes, they're similar on some characteristic. Strata are based on facts known before the sample is selected. Would I need to know what grade they're in before I can select my sample? Yeah. Each individual unit in the population belongs to one and only one of the strata. And that's one that I probably take for granted and don't mention as much. It wouldn't work if you could be split up in multiple groups because then you might be selected more than once. That doesn't make it fair. E, every possible subset of the population of the desired sample size has an equal chance of being selected. If that doesn't ring a bell and make an obvious thing for you, then you need to write this down. That is word for word the definition of what?
Simple random sample.
And you will see that on the exam. Maybe not this exact wording, but you will see something in multiple choice with simple random sample. There aren't many things where I can say you'll definitely see it, but that's pretty much one of them. So, is simple random sample the same thing as a stratified random sample?
No.
No. So your answer is E. Yeah.
What's the one that's like you pick like every fifth?
Yeah. So our main sampling techniques are simple random sample, stratified, cluster, and someone that we don't talk about very much. Does anybody remember that name?
Systematic.
And very generally, what happens in systematic?
Every inch person is selected.
So what's implied that happened before that? That happens a lot of times with production line. When they want to check and make sure that stuff's working correctly, they select every 75th one or something to make sure nothing's changing. I don't think there's any. I guess it's it with that. So that gets us to what, 14? 15. Okay, this might be the last one we'll talk about. Alright, distribution, so number 10. I get why people miss this problem a lot. It's not really super complex. I think they're just not thinking about the right thing. A distribution of diameters of a particular variety of oranges is approximately normal. I haven't talked about this in some of the other problems, but what does it really mean to us when it says approximately normal, as far as our class is concerned? We can what? Use normal approximation. We can use yellow, right? Yellow, green. With standard deviation of 0.3 inches. How does the diameter of an orange at the 67th percentile compare with the mean? You should be able to never do any math at all and narrow this down to 3 answer choices very, very, very quickly. What does that mean?
Above 50%.
You're above the 50th percentile. You do better than 67% of the people, which means you are better than the mean. So which of these answers should you immediately mark out?
Below the.
So if you've noticed, a lot of the problems that are even hard problems, you should be able to look out and knock out at least 1 or 2 answer choices before you even start the problem. Alright, so now let's actually go backwards here. So let's start from here. And this is where I think some of you just were like, oh, I wouldn't have thought to do that. Percentile always means shade what? Alright, so I'm over here somewhere to be more than 50 to be able to shade left more than 50%. And this amount is 0.6700. What can I do with that?
Look at your yellow sheet.
Look at your yellow sheet. Since this is the last one I'm going to be doing and we've got plenty of time to do it, let's actually go ahead and do this. So our yellow sheet is essentially broken down into 2 things. Something on the outside and something on the inside. What are the things on the outside of your yellow sheet? Your z-scores, what is on the inside? Your probabilities are your areas. So I'm going to be looking for this in this area probability section. I'm going to find the closest thing to 0.67 and then do what with that? Just follow it out. So what is the closest thing that you follow out from 0.67? It's like you're looking in here for the closest thing to 0.6700. And you follow it out to this number to get our z, and you end up getting a z of what? 0.44, right? And that's where I think some of you wouldn't have thought to go that direction. I'll come back to this in a second. What does z actually equal? What's our equation? Our very basic equation. Alright, so we know that our z-score is 0.44. We know our standard deviation is 0.3. But we don't know our x or our x bar. So what can I do with that? The 0.3. Multiply it. And that gives me the distance from mine to the mean. How does it compare to the mean? That's how far it is from the mean. So 0.44 times 0.3 gives you what? So our answer is if you didn't go to here with it, in words, what is a z-score? From what? We are 0.44 standard deviations above the mean. So I can think about it this way. Well, 0.3, that's over a standard deviation. That's about 2/3 of the standard deviation. I need to be less than half. That's the only one that's less than half the standard deviation. Questions is where we are right now.